The next key area that we're going to be discussing now, that would be the sampling design. So what is meant by sampling then? If we say sampling, it may be defined as a measuring or as measuring a small portion of something and then making a general statement about the whole thing. For example, one is buying mangoes, okay? He picks up one mango from a crate of mangoes and tastes it. If the mango is sweet, then he concludes and says that the mangoes in the crate are sweet, although he has tasted only one mango. So this is what we mean by sampling. So why we need sampling, or what's the purposes and advantages of sampling? So there are some advantages of sampling, some of which are the following. First, sampling makes possible the study of a large heterogeneous population. What do we mean by this? It means that the universe or population to be studied may be too large or unlimited, that it is almost impossible to reach all of them, correct? Now, suppose the age distribution of the entire population of the country is to be studied. It is surely very difficult, if not entirely impossible, to reach every person of the whole country, if that makes sense, right? Therefore, sampling makes possible this kind of study because in sampling, only a small portion of the population may be involved in the study, enabling the researcher to reach all through this small portion of the population. And another purpose and advantage of sampling, that would be sampling is for economy. This means that research without sampling may be too costly. Take, for instance, that a study involves the whole population of a town of 70,000 people. Now, to make questionnaire copies for 70,000 is surely an expensive affair, correct? Now, this being said, the expenses are even greater if interviewers are employed to interview every person of that group, numbering to 70,000. However, sampling reduces the study population to a reasonable size, that expenses are greatly reduced. And another purpose and advantage of sampling, that would be sampling is for speed. This means that research without sampling might be too time consuming. For example, to reach the 70,000 persons for an interview would surely entail a long time unless many interviewers are employed, right? Now, if our research takes a long time to finish, then there may be many intervening factors that deter the researcher from finishing his research. And another purpose and advantage of sampling, that would be sampling is for accuracy. Now, this means that if it takes too long a time to cover the whole study population, then there may be inaccuracy. So by the time the last person is interviewed, the data gathered from the first interviews may be obsolete already, so that the conclusions are no longer accurate, right? So therefore, the research must be finished within a reasonable period of time so that the data are still true, valid, and reliable. And finally, sampling saves the sources of data from being all consumed, meaning the act of gathering data may consume all the resources or may consume all the sources of information without sampling. So for example, suppose we want to find out whether bread baked in a certain bakery is delicious. So without sampling, we have to consume all the bread baked in the bakery before making any conclusions, right? Now, in such a case, there is no more bread to apply the conclusion to, which is actually correct. All right. Now, in order for us to better understand a sampling design, we need to get ourselves be acquainted to the different terminologies under sampling technique or sampling concepts. So all the definitions here are from Babi, although some explanations are added for local adaptations. Now, these are some of the sampling concepts and terminology. So first, we have element. What do we mean by element? If we say element, an element is that unit about which information is collected and which provides the basis of analysis. So they are the members of the population, in short. So these are certain types of people, families, social clubs, and the like. So elements and units of analysis are often the same, but the former refers to sample selection, while the latter refers to data analysis. For example, the families in Islam area are the subject of an investigation. While selecting the families to be included in the sample, they are called elements, but when data have already been gathered and being analyzed, the families are called units of data analysis. Okay, so those are the difference between the two. Another sampling concept and terminology is called population. If we say population, it is the theoretically specific aggregation of the elements. So this is the so-called universe. So suppose a study is to be conducted to determine the profile of college students of a certain university. So the term population includes all the college students, whether full-time, part-time, professional, working, male or female students, okay? And if we say study population, a study population is that aggregation of elements from which the sample is actually selected. For example, in the study of college students, only the full-time male and female students may be included. All other types of students are excluded. So this is the study population, which is often defined in the scope and delimitation section of thesis report. Another sampling concept and terminology is what we call sample. So if we say sample, these are the elements or people who are actually selected to participate or to be the subject in the study. And if we say sampling unit, a sampling unit is that element or set of elements considered for selection in some stage of sampling. So in a simple single stage sampling, the sampling units are the same as the elements, okay? However, in a more complex sampling, let's say different levels of sampling units may be employed. For example, you may select a sample of census blocks in a city, then select a sample of adults, of which only the last of these are the elements. For example, you may select a sample of census blocks in a city, then select a sample of adults, of which only the last of these are the elements. The first sampling unit is called primary sampling unit, which refers to the census blocks. And the second unit is called the secondary sampling unit, which refers to the household. And the third unit is called the final sampling unit, which are the adults, okay? And another sampling concept and terminology is what we call sampling frame. If we say sampling frame, it is the actual list of sampling units from which the sample or some stage of the sample is selected. So if a sample of students is selected from a student roster, the roster is the sampling frame. So in a single stage sampling design, the sampling frame is the list of the elements composing the study population. On the other hand, if we say observation unit, an observation unit or unit of data collection is an element or aggregation of elements from which information is collected. Now, the unit of analysis and observation unit are often the same, the individual person, but not always the same. Therefore, the researcher may interview the heads of households, which refer to the observation units, to collect information about all members of the households, which refer to the units of analysis. So in other words, the observation units are the actual respondents to a study. So the observation units or respondents are the people who are interviewed or who are requested to accomplish questionnaires for data collection. Another, we have variable. So what do we mean by variable? Well, a variable is a set of exclusive attributions. Examples are sex or gender, we have age, we have employment status, and so on and so forth. So the elements of a given population may be described in terms of their individual attributes on a given variable. Therefore, a researcher may describe the age distribution of a population by examining the relative frequency of their ages. So a variable must possess variations. If all elements in the population possess the same attribute, that attribute is constant in the population rather than a part of a variable. And another, we have parameter. If we say parameter, it is the summary description of a given variable in a population, meaning the mean income of all the families of a city is an example of a parameter. And the mean age of all the people in a city is also an example of parameter. So the age distribution of all people is a parameter. So what about statistics? If we say statistics, a statistics is the summary description of a given variable in a sample. Therefore, the mean income computed from a sample and the age distribution of that sample are considered to be as statistics. Now, sample statistics are used to make estimates of population parameters. For sampling error is the degree of error of a sample statistics when compared with the population parameter. For example, if the population mean is 80 or 80 and the sample mean is 40 or 40, then the sampling error is 40 or 40. So the acceptable maximum sampling error is 5%. Take note. And another concept, sampling concept and terminology is representative sampling. A sample will be representative of the population from which it is selected if the aggregate characteristics of the sample closely approximate those same aggregate characteristics in the population. A sample will be representative of the population from which it is selected if all members of the population have an equal chance of being selected in the sample. So this means that all characteristics, differentiated groups or classes in the population must be proportionally represented. So for example, if there are 50% or 50% women in the study population, there must also be 50% or 50% women in the sample. So suppose the study population is 100, 60 of whom are women and 40 are men. So if the sample is 20% of the population, then there should be 12 women and 8 men in the sample. And also we have confidence interval. If it's a confidence interval, it is the degree of confidence that a sample statistics will accurately fall within a certain or specified interval from the population parameter. So the interval called the confidence interval is the range within which the sample statistics should fall. So the interval is expressed as plus or minus the sample statistic. Suppose the sample mean is, let's say, 75, and the confidence interval is plus or minus 8. And the level of confidence is 95%, then we say that we are 95% confident that the population mean falls within plus or minus 8 to or from 75. Hence, the confidence interval or range is from 67 to 83. So 75 minus 8, that's equal to 67, and 75 plus 8 is equal to 83. All right? And finally, the last sampling concept and terminology is what we call sampling stratum. So a sampling stratum is that group or group section or category of elements from which selection is made in some stage of sampling. So in a single stage sampling, the sampling stratum is the whole population. However, in a more complex sampling, different levels of sampling strata may be employed. For example, you may select a sample of census blocks in a city, then select a sample of households from the selected blocks, and finally, select a sample of adults from the selected household. So the city is the primary sampling stratum, the census blocks are the secondary sampling stratum, and the households are the final sampling stratum. All right. So these are the different sampling concepts and terminologies that we should always remember and we should always get ourselves acquainted to and also familiarize. And another, we have principles of sampling. So there are three principles of sampling, and the first one is appraisals that involve sampling are estimates and predictions only. And second, estimates based on sampling are least accurate when the sample is a small proportion of the whole and when the sample is not representative. Conversely, estimations based on proportionately large samples and on representative samples are most accurate. So, for example, sample means the portion of a population taken as the subject of a study. A sample is representative if it is taken from all sections or groups of a population in equal proportion. Okay? And lastly, sampling may be categorical or temporal, meaning sampling is categorical if the sample is taken proportionally from categories or groups. On the other hand, sampling is temporal when the sample is in terms of time, as for example, the pulse of a patient is taken every 10 minutes. Okay, so that's what we call temporal. And if sampling has advantages, we also have disadvantages of sampling. This is called defective sampling. So one disadvantage of sampling is that if sampling is biased or not representative or too small, then the conclusion may not be valid and reliable. So here is an example of a representative sampling. Suppose the teaching of science is to be studied in a certain high school with the students from first year to fourth year as respondents, okay? The population or universe consists of all the high school students. A portion of 20% are to be taken as respondents. This constitutes the sample. Suppose the students are divided into sections according to ability. So the diagram illustrates how a representative sample is taken. So take the first year students who are sectioned in three according to ability. Okay, so you have there 4 columns. As you can see on the presentation, you have section 1 as section number, and second column you have the gender. Third column, you have the total number of population. And fourth column, you have the percentage, okay? Now, as you can notice, as far as the first year students are concerned, 140 is the population and 28 is the sample, which is representative of that population, right? So the same should be done with the second, third, and fourth years. So if the students are lumped up together, or meaning combined, and then the 20% will be taken from the whole, then the sampling is biased and not representative because more might be taken from one section, or there may be more males than females, right? If that makes sense. And the second disadvantage is that in research, the respondents to a study or the sample must have a common characteristic, which is the basis of the study. Now, if some of the sample do not have this common characteristic, then the conclusions become faulty. For example, in the example given in number 1, The common characteristic of the sample or population is that all of them are high school students, right? If some college students enter the sample, then the conclusions may become erroneous. And third disadvantage, if the population is very large and there are many sections and subsections, the sampling procedure becomes very complicated. So it would be difficult to assign numbers to the elements, which refer to members of the population, or it would also be very difficult to write their names alphabetically on pieces of paper to be placed in the raffle box. And finally, the last disadvantage is that if the researcher does not possess the necessary skills and technical know-how in sampling procedure, then the sampling may become biased and unrepresentative. All right. Generally, data collection can be classified into two. Namely, we have a census and survey sampling. So what's the difference between the two then? If it's a census or a complete enumeration, it is a method of gathering data from every unit in the population. However, this is not always feasible because at times the population is unknown and therefore the population frame is not always available. And besides, conducting a census entails a large amount of money, time, and effort. And on the other hand, survey sampling is a method of gathering data from every selected sample in a given population. So in most cases, many researchers utilize survey sampling because it reduces cost, it has greater scope, speed, and accuracy as well. Now, survey sampling can either be probability and non-probability sampling. Now, what's the difference between the two? If we say probability sampling, it is a sampling procedure in which every element in the population has a known non-zero chance of being included in the sample selection. And on the other hand, if we say non-probability sampling, it does not utilize random sampling, and hence it is generally short of knowing ways as to how representative a sample is. Now, in order for us to better understand each one of them, let us discuss them one by one, starting with probability sampling. Now, as you can see, under probability sampling design, it includes simple random sampling, stratified random sampling, systematic random sampling, cluster sampling, and we also have multi-stage sampling. And so for that matter, let us discuss first what simple random sampling is. If it's a simple random sampling, this is a sampling procedure in which every element in the population has an equal chance of being included in the sample. Here, we select n units out of n units in the population, the selection of which is through, let's say, lottery, raffle, or the use of random numbers. Okay, so that is simple random sampling. Another sampling technique under probability sampling design, that would be stratified random sampling. So what is meant by stratified random sampling then? If we say stratified random sampling, in the stratified random sampling, the population of n units is divided into subpopulation called strata, which consists of more or less homogeneous units. Then from each stratum, a simple random sample procedure is performed in order to select the samples, the selection of which is independent in each strata. So thus, to assure of homogeneity of units, a stratification variable is first defined. Now, in order for us to better understand stratified random sampling, let me give you an example. So for example, in a study to determine the student's preference over socialized tuition fee at ABC University, a researcher may employ stratified random sampling by stratifying all students of ABC University, which is the population, by colleges or stratification variables. So as you can notice, we stratified, what we did here is that we stratified the population into stratification variables. So we have stratified this one according to colleges. So we have the College of Commerce, College of Engineering, College of Education, College of Arts and Sciences, College of Nursing, College of Pharmacy, and we also have College of Dentistry. Now here, we have 7 strata or the colleges, and for each stratum, the researchers may now proceed to select the samples using simple random sampling procedures. So how do we do that? So we will do that by making use of this way. Now, if the stratification variable is by college, then we have 5 strata, and the population is stratified as the year level. So in this case, we have first year students, second year students, third year students, fourth year students, and fifth year students respectively. Okay, so this is what we call stratified random sampling. And another sampling technique under probability sampling design is called systematic sampling. So what is meant by systematic sampling then? If we say systematic sampling, this is a sampling procedure which selects the sample by taking every case unit from an ordered population. Now here, K is called the sampling interval and is defined as K equals capital letter N all over small letter n, where capital letter N refers to your population size and your small letter n refers to your sample size. Now, the selection of the n samples is usually done by a random start and every kth unit thereafter. Now, in order for us to better understand how to calculate or solve systematic sampling, then let me provide you an example. So for example, suppose we select n equals 13 students from a population of size n equals 40. So to employ systematic sampling, we first determine your K. Again, K is your sampling interval. So K equals n over n. Now, by simply plugging in the values to our formula, then the amount of our sampling interval, that would be 3. Hence, from an ordered population, so as you can see on the sample, you have there 40 students, which are ordered 1 to 10, 11 to 20, 21 to 30, 31 to 40. So we have 40 students as our population. And remember, we only need to select 13 students out of 40. And also, based on our calculation, our K or sampling interval is 3. So what's the first thing that we need to do in doing the selection? Okay, here, let's assume that we select the student number 8 first, okay? Because the selection, remember, it is just a random selection and the researcher has the right to select which student he or she is going to select randomly. So in this case, let's just try to select number 8 student. Okay, we have number 8. And since we have encircled number 8, meaning we have selected student number 8. So that's our first selection. So we now have remaining of 12 because we are only tasked to select 13 students out of 40 rather. Now, since our sampling interval is 3, that means to say that we need to count 3 from student number 8. So if we try to count 3, so 1, 2, 3. So we will stop at student number 11. And so for that matter, we will select student number 11. And again, we will count 3. 1, 2, 3. So for that matter, we will select student number 14, and then student 17, student 20, student 23, student 26, student 29, student 32, 35, 38, student 1, and student number 4. So if you will try to count, if this is 13 all in all, so we have 1, 4, 8, 11, 14, 17, 20, 23, 26, 29, 32, 35, and 38. And yes, we have finally selected 13 students out of 40 population. All right, so this is what we call as systematic sampling. Another sampling technique under probability sampling design is what we call purposive sampling. So what do I mean by purposive sampling? If we say purposive sampling, it is about determining the target population, those to be involved in the study. So the respondents are actually chosen on the basis of their knowledge of the information desired. Now, if research is to be conducted on a history of a place, the old people of the place must be consulted, right? And if methods and techniques of teaching are the subjects of an inquiry, then teachers are the ones contacted. And if the topic of investigation is the production of rice, then the respondents must be rice farmers and agriculturists. However, the actual selection of respondents is done either by simple random sampling or systematic random sampling. If the population is composed of differentiated groups, then stratified random sampling must be utilized. And another sampling technique under probability sampling design is what we call cluster sampling. This is also known as area sampling. So this is a variation of stratified random sampling in which the strata corresponds to clusters. Now, the units of these clusters, however, possess heterogeneous characteristics or attributes. Now, cluster sampling in itself is especially useful in researches or studies comprising of big or large populations. Thus, in many cases, the clusters consist of geographic units like barangays, cities, municipalities, provinces, or blocks of streets. Now, this explains why cluster sampling is also known as area sampling. Aside from that, cluster sampling is also used when the population is so big or the geographical area of the research is so large. Now, the general procedure is to divide the area or population into clusters or blocks, and then within the final cluster, apply any of the different methods of selecting a sample. So, for example, supposing a study is to be conducted to determine the standard of instruction in a certain region of the country in elementary schools. Now, take for granted that there are 9 provinces in the region and the proportion of the population to be the sample is 20%. Now, the steps are, first, you need to make a listing of the sampling units, the primary sampling units, or the first clusters to be sampled, the secondary sampling units, or the second clusters to be sampled within the primary sampling units, etc. Now, suppose the provinces are the primary sampling units, the towns are the secondary sampling units, and the barangays as the final sampling units. So these are called natural clusters. And second, since the sample is 20%, then 20% of the 9 provinces equals 1.8 or 2 provinces. Now select these 2 provinces by either a simple random or systematic random sampling. And third, within each of these 2 provinces, select 20% of the towns either by pure or simple random sampling or systematic random sampling. And finally, within each town selected, choose 20% of the barangays or barrios. Now, since there is only one elementary school in one barrio or barangay, this is the final sampling unit or cluster. So the respondents in the study are to be selected from these final clusters. So the respondents may be stratified into teachers, administrators, parents, and pupils. The respondents have to be taken from these stratified groups by either simple random or systematic random sampling. Now, the advantage of the cluster sampling is its efficiency. Its main disadvantage is its reduced accuracy or representativeness on account of the fact that in every stage, there is a sampling error. And finally, the last type of probability sampling design, that would be multi-stage sampling. If it's a multi-stage sampling, this is a sampling procedure wherein the population is divided into a sequence of sampling units corresponding to the different sampling stages. Another type of survey sampling is what we call non-probability sampling design. Now, non-probability sampling techniques are those that do not utilize random sampling. Hence, these are generally short of knowing ways as to how representative a sample is. Now, these techniques include accidental sampling, quota sampling, and convenience sampling as well. Now, what's the difference between the three? If we say accidental sampling, in this type of sampling, there is no system of selection, but only those whom the researcher or interviewer meet by chance are included in the sample. For instance, the interviewer stands in a street corner and he interviews everyone who passes by, okay? Now, the problem with this type of sampling is its lack of representativeness. Now, the sample might be biased one. If the place where the interviewer stands is a business section, then most of the people who pass by are business and rich people, and therefore, the respondents are only well-to-do people. Now, if the place where the interviewer stands is a slum area, most of the people who pass by and interviewed are poor people. So in research, every section of the population being studied must be proportionally represented in the sample. Now, accidental sampling is resorted to only when there is no other alternative. So that is why it's considered as non-probability sampling design. And on the other hand, another example of non-probability sampling design is quota sampling. What do we mean by quota sampling? In this type of sampling, specified numbers of persons of certain types are included in the sample. So suppose the reactions of people towards a certain issue is to be determined and a cross-section of the population must be involved. Now, it might be decided that 10 doctors, 8 lawyers, 15 businessmen, 20 vendors, and 25 farmers should constitute the sample. Now, what's the advantage of quota sampling then? Well, the advantage of quota sampling over accidental sampling is that many sectors of the population are represented. However, its representativeness is doubtful because there is no proportional representation and there are no guidelines in the selection of the respondents. Any one of the groups selected to participate will do. Any doctor or any lawyer who like to participate will be included in the sample. And another danger is that the perception of the minority may become typical in the findings. So if the majority of the sample, for example, are professionals who are in the minority of the population, then their perceptions may become predominant over those of the non-professionals who are in the majority of the population. Again, quota sampling may be used only when any of the more desirable types of sampling will not do. And finally, the last type of non-probability sampling design is what we call convenience sampling, or also known as haphazard sampling. If we say convenience sampling, it is a process of picking out people in the most convenient and fastest way to immediately get their reactions to a certain hot and controversial issue. So if there is a hot and controversial issue, say the raising of price of gasoline, the most convenient and fastest way of reaching people is by telephone to be able to interview them at once. So the interviewer contacts people who have telephones and asks them what their reactions are the issue to at hand. Now, this type of sampling is certainly biased and not representative, considering that the people who have telephones are a class by themselves, and so their views cannot be considered as views of the people. It should be noted that even in ordinary data gathering in research, interviews can also be conducted through the telephone, provided that those interviewed by telephone are only among those who are properly selected to be included in the sample. So it only happens that these people have telephones. So the guidelines for determining adequate sampling. So take note that the size of your sample is usually determined before the conduct of any study, okay? Now, there are no fixed rules in determining the size of a sample needed. However, there are broad guidelines that should be observed in determining the size of a sample. And among these guidelines are the following. First, when the universe or population is more or less homogeneous and only the typical, normal, or average is desired to be known, a smaller sample is enough. However, if differences are desired to be known, a larger sample is needed. And second, when the population is more or less heterogeneous and only the typical, normal, or average is designed to be known, a larger sample is needed. However, if only their differences are desired to be known, then a smaller sample is sufficient. And third, the size of a sample varies inversely as the size of the population, meaning a larger proportion is required of a smaller population, and a smaller proportion may do for a bigger population. So for a population of 5,000, a sample of 10% may do, but for a population of 500, proportion of 30% may be required. And number four, for a greater accuracy and reliability of results, a greater sample is desirable. And number five, in biological and chemical experiments such as testing and effects of drugs and other substances, the use of a few persons is more desirable to determine the reactions of humans to such drugs and other substances being tested. Okay? And number six, when the subjects are likely to be destroyed during the experiment, then it is more feasible to use non-humans such as animals, especially rats. Okay? Now, what are the steps in computing the size of the sample then? Well, the steps in computing the size of a sample are as follows. So the very first thing that we need to do is to determine the size of the study population. This is easily determined from the scope and delimitation of the study. And second step, decide on the margin of error. So as much as possible, the margin of error should not be higher than 5%. And number three, use the formula in calculating the sample size. So as you can see, this is Slovin's formula, and this is going to be the formula that we're going to be using in calculating our sample size. So Slovin's formula is N equals capital letter N all over 1 plus NE raised to the power of 2, where small letter n refers to the desired sample size, capital letter N refers to the population size, and your E is your margin of error, which is usually set at 0.05 or 5%. And step number 4, if the sampling is multi-stage or if the population is stratified, then you need to compute the sample proportion by dividing the result in step number 3 by the population. And number 5, you need to multiply the number of sampling units in each final sampling stratum by the rate to find the sample from each final sampling stratum. And finally, you need to add the samples from all the final sampling strata to find the total sample. Now, in order for us to better understand how to calculate the size of our sample or the sample size, then allow me to provide you an example. So for example, suppose an investigation of the teaching of science in the high schools of a region is to be conducted, in which the science teachers are to be made respondents. Now there are 500 teachers handling biological sciences, 300 handling chemical sciences, and 200 teachers handling physical sciences, for a total of 1,000 teachers. So by simply making use of our steps or applying our steps in calculating the size of a sample. So step number one, our population is 1,000, since there are all in all 1,000 teachers. And step number two, the margin of error to be used is 3%. And step number three is the computation of the Sloven's formula. We will be using the Sloven's formula to get our sample size. Now, as you can see, by simply plugging in the values to our formula, then our sample size is 286 respondents. Okay, so this will be our sample size. And step number four, the teachers are grouped into three categories according to the branch of science they are handling. So we use stratified sampling. So since we will be using stratified sampling, so in this case, we need to calculate our sampling proportion, which is expressed in terms of percentage. And the formula in getting the sampling proportion, that would be your sample all over your population size. Now, as computed in step number three, our sample size is 286 divided by the total number of population, 1,000. So our sampling proportion in this case, that would be 29%. And step number five and steps number 5 and 6. So this is how we will be calculating our sample sizes for each subject handled. As you can see on our presentation, in the first column, you have the subject handled by our science teacher, followed by the population column, the sampling proportion, and the sample size. Now, as you can notice, like I said earlier in our problem, the teachers are divided into three categories. So these are the subjects handled. So we have biological sciences, chemical sciences, and physical sciences, respectively. So based on our example, there are 500 teachers who teach biological sciences, 300 under chemical sciences, and 200 teaching physical sciences, for a total of 1,000 teachers all in all. Now, since as computed, our sampling proportion is 29% rather, then we need to calculate our sample size by calculating or by computing 500 multiplied by 29%. So 500 times 29%, that's 145 samples or teachers. 300 multiplied by 29%, that's 87 teachers. And 200 multiplied by 29%, that's 58 teachers. So therefore, in this case, if we are employing stratified random sampling, then instead of using 286 sample size, we will be using instead 290 sample size, okay, as per calculated. All right, so this is how you calculate sample. The last key area that we're going to be discussing now, that would be statistical treatment of data. The last part of this chapter usually describes the statistical treatment of data. And take note that the kind of statistical treatment depends upon the nature of the problem, especially the specific problems, and the nature of the data gathered. And the explicit hypothesis particularly determine the kind of statistics to be used. So what is meant by statistics then? So if we say statistics, according to the American Statistical Association, or ASA, statistics is the science of learning from data. And in singular sense, it is a branch of science which deals with the collection, presentation, analysis, and interpretation of results objectively in the presence of uncertainty. And if we say statistical treatment of data is when a researcher applies some form of statistical methods to a data set to draw meaning from it. And statistical treatments can either be descriptive statistics and inferential statistics. So we will be discussing this one in detail later on. So what is then the scope or coverage of statistics? Well, statistics is divided into two scopes. First, we have the branch of knowledge, and second, we have data. And it is a branch of knowledge because we collect data, we represent data, or we present data, we analyze the data, and then we interpret the results. And in collecting data, there are actually different data gathering techniques that we can use, such as interviews, through conducting survey questionnaires, through observation, or through recording. And in presenting the data, what we usually do is to organize them to aid better understanding. We can organize them by means of textual, graphical, and tabular presentation. Now, there are three ways of analyzing our data. First, we have univariate. Second, we have bivariate. And third, we have multivariate. When we say univariate, this is the simplest form of analyzing data. Uni means one. So in other words, your data has only one variable. Most importantly, the very thing that we need to take note if we talk about univariate analysis is that it doesn't deal with causes or relationships, and its major purpose is only to describe. On the other hand, if we say bivariate analysis, your data is composed of two variables. And because it has two variables, it involves relationships between the two variables. And lastly, if we say multivariate analysis, it is a set of techniques used for analysis of data sets that contain more than one variable. And the techniques are especially valuable when working with correlated variables. And in interpretation of results, it can either be narrow or broad interpretation. When we say narrow interpretation, it is a brief and concise one, while broad interpretation is long and detailed. Now, the second scope of statistics is data. As you can see, there are four types of data and measurement scale. We have nominal, ordinal, interval, and ratio. If we say nominal data, these are used for labeling variables without any quantitative value. It could simply be called labels. Again, if we talk about nominal, there is one key term that we should always remember, and that is to name. So by the name itself, nominal, to name. So that's the key term that we should always remember. It's either to name or to label. Now, examples of nominal data, that would be if you are answering a survey questionnaire or a Likert scale, most likely you will be asked, what is your gender? So gender, it can either be male or female. So you are just simply naming or labeling. Aside from gender, you will be asked as well, what is your hair color? So is it brown, black, blonde, gray, or other? Okay, so if I choose brown, then you are just simply naming or labeling. So that's nominal data. If we say ordinal data, by the
term itself ordinal. So meaning, if in nominal, the key term that we should always remember is to name, on ordinal data, the key word that we should always remember, that would be order. Again, it's order. If we say ordinal, it is the order of the values is what's important and significant, but the differences between each one is not really known. So for example, again, going back to a survey questionnaire or a Likert scale. So if you're answering a survey questionnaire, you will also be asked, how do you feel today? So there is an order of your feelings. So for example, number 1, very unhappy. 2, unhappy. 3, okay. 4, happy. And 5, very happy. Okay, there is an order. Okay, that's ordinal data. So how do you feel today? Based on our example, in each case, we know that number 4, example, from a point scale of 1 to 5, where 5 is the highest and 1 is the lowest. Now, based on our example earlier, in each case, we know that number 4 is better than number 3 and number 2 feeling, right? But we don't know, and we cannot quantify as well how much better it is. For example, is the difference between okay and unhappy the same as the difference between very happy and happy? We can say so. So it is typically measures of non-numeric concepts like satisfaction, happiness, discomfort, etc. For example, how satisfied are you with our service? Using a point scale of 1 to 5, where 1 is the highest and 5 is the lowest. So 1, very satisfied. 2, somewhat satisfied. 3, neutral. 4, somewhat unsatisfied. And 5, very unsatisfied. So again, going back, if we see ordinal, the key word that we should always remember is order. So there is a certain ordering. And next type of data or measurement scale is interval scale. In nominal, the keyword is to name. In ordinal, the keyword is order. Here in interval, the keyword that we should always remember is space in between. Again, space in between. So what is meant by interval data then? If we say interval data, these are numeric scales in which we know not only the order, but also the exact differences between the values. For example, let's say temperature. So Celsius temperature. Because the difference between each value is the same, for example, the difference between 60 degrees and 50 degrees is a measurable of 10 degrees, right? Also with the difference between 80 degrees and 70 degrees as well. So aside from temperature, another example under interval data, that would be time, because its increments are known, consistent, and measurable. Remember that interval scales are nice because the realm of statistical analysis and these data sets opens up. Example, we have central tendency. Central tendency can be measured by mode, mean, and median. Standard deviation can also be measured. All right, so this is about interval data, and the keyword to remember, space in between, because we can measure it. Next, we have ratio data. If we see ratio data, these are the ultimate nirvana when it comes to measurement scales, because they tell us about the order, they tell us the exact value between units, and they also have an absolute zero, which allows for a wide range of both descriptive and inferential statistics to be applied. What do we mean by absolute zero? One example that we provided in interval data was temperature, right? And temperature doesn't have an absolute value because there is even a temperature that is below zero. Let's say negative 10 degrees temperature, right? So aside from temperature, we also have time. And take note that time doesn't have any absolute zero as well. It doesn't start from 0, 1, and so on and so forth, right? So in ratio data, it has an absolute zero. So for example, or the height of a building, okay, it starts with 0, meaning to say there is an absolute zero. Okay, moving on to divisions of statistics. So what are the two divisions of statistics? The two divisions of statistics, we have descriptive statistics and we also have inferential statistics. What do we mean by descriptive statistics? If we say descriptive statistics, it pertains to the methods dealing with the collection, organization, and analysis of a set of data without making conclusions, predictions, or inferences about a larger set.
Examples of descriptive tools that would be ratios and rankings. We also have measures of central tendency or location. And as you can recall in your statistics subject, a summary measure of location is a value around which most of the data values tend to congregate or center. Now, in this section, the three measures of location are the mean, median, and the mode. As you will see, the choice of the most appropriate measure depends crucially on the type of data involved. If we say mean, among the three measures of central tendency, the most widely used central measure of a distribution is the arithmetic mean. And the mean of a data set is the sum of the data values divided by the number of data values. On the other hand, if we say median, if we arrange the data in ascending order of size, the median is the middle value. And therefore, half of the values will be equal to or less than the median value, and half equal to or above it. So the median is therefore a measure of centralness. And if we say mode, the mode is that category or value in that data that has the highest frequency or occurs the most often. And in this sense, the mode is a measure of commonness or typicalness. Since the mode is the measure of typicalness, it is appropriate to compute for the mode of data which are categorical or qualitative in nature. For example, there are 6 students whose score is 36 and all the rest are different from each other. So it is clear that the modal score is 36. And another example of descriptive tools is measures of variability. Now, measures of central tendency, if you can notice, give us measures of where the middle of a set of data occurs, but this is not enough to characterize a set of data. Therefore, the common measures of variations are the range, the variance, the standard deviation, and the coefficient of variation. Now, if we say range, it is the difference between the highest value and the lowest value in a data set. And to compute it, simply subtract the lowest value from the highest value. And if we say variance, the variance is the average of the squared variations of the observations from their arithmetic mean. And if we say standard deviation, a more accurate measure of variation can be given by the standard deviation of the data. So standard deviation shows how much variation or dispersion exists from the average or the mean or the expected value. If we say dispersion, this is the scattering of values of a frequency distribution from an average. And another example of a descriptive tool is the measures of position. Now, in this section, measures of relative standing, which are numbers showing the location of data values relative to the other values in the data set, are introduced. the most important concept is the standard score or the z-score. So what do we mean by z-score then? If it's a z-score or standardized score, it is the number of standard deviations that a given value x is above or below the mean. Just like an old saying, you cannot compare apples and guavas, but with the use of statistics, it can be done to some extent. So for example, suppose that a student scored 90 or 90 in math and 45 or 45 in English. Now, direct comparison of their raw scores is impossible since the exams might not be equivalent in terms of number of questions, value of each question, and so on. However, a comparison of relative standards similar to both can be made. So this comparison uses the mean and standard deviation and is called a standard score or z-score. Also, we have percentile or centile. It is the value of a variable below which a certain percent of observations fall. These are position measures used in educational and health-related fields to indicate the position of an individual in a group. Now, percentiles divide the data set into 100 equal groups. So the percentile corresponding to a given value x is computed by using the following formula. So we have percentile is equal to the number of values below x plus 0.5 all over total number of values, and then it will be multiplied by 100%. And on another hand, we also have quartiles. And if we say quartiles of a set of values are the 3 points that divide the data set into 4 equal groups, each representing a fourth of the population being sampled. And finally, we have deciles. And if we say deciles, they divide the distribution into 10 groups. They are denoted by D sub 1 to D sub 9, and that D sub 1 corresponds to P sub 10, D sub 2 to P sub 20, and so on and so forth. All right. Another example of descriptive tool that would be statistics of associations, and it includes bivariate correlation, which includes Pearson correlation, and we also have regression coefficients. Another example of descriptive tool is what we call the tabular methods of summarizing data. Take note that the tabular methods of presenting data take any form, which depends on the type of variable being summarized and presented. And as you can notice, the most commonly used way to tabulate data is to construct a frequency distribution table or FDT by grouping the raw data into categories along with the number of observations falling into each category. So a frequency distribution table is one way you can organize data so that it makes more sense. So it could give a better picture of your data than a simple list. So there are different types of frequency distribution tables depending on the level of measurement, nature, and the size of data collected. So these include the simple frequency distribution. And if it's a simple frequency distribution, this type of table provides a useful way to present data when the dependent measure is discrete or nominal level variable. On the other hand, if we see regular or ungrouped frequency distribution, this is a type of table or distribution that is used when there are a small number of observations, meaning it is merely a tabular arrangement of data that shows the frequency occurrence of the different values of the variables. So usually the arrangement is in descending order of magnitude. And also we have grouped frequency distribution. And grouped frequency distribution table is used when there are so many values of the variable being analyzed. So presentation of data is improved by grouping the values of the variables into non-overlapping or mutually exclusive categories. So these variables of non-overlapping or mutually exclusive categories are called class intervals or simple classes. And they are arbitrarily defined ranges of the variable, and each class interval is defined by its upper class limit and lower class limit. So the class limit specifies the magnitude of values that go on into a class interval. If you get the average of the lower limit and the upper limit of an interval, then the result is called the class midpoint. It is usually denoted by capital letter X. And the number of observations that belong to that class is called your class frequency. And finally, you have cumulative frequency. If I say cumulative frequency, it enables us to determine at a glance the number of observations that are less than or equal to the upper class limit, or the number of observations that are greater than or equal to the lower class limit of a given class interval. Actually, cumulative frequency is under grouped frequency distribution. And another example of descriptive data is what we call the graphical depiction of data. Now, take note that today, decision makers are being blitzed by data, right? And therefore, the medium of the information communication can be very essential. So one of the most widely used media of transferring information is graphic depiction, or by means of visual aids such as graphs. So converting data to graphics can be creative and artful. And often, the most difficult and crucial step in this process is reducing important and sometimes expensive data to a graphic picture in a manner that is clear and concise, yet consistent with the original message of the original data. Now, there are several types of graphic depiction which are presented in either histograms or bar graphs. We have line graphs and frequency polygons and pie charts. Some also uses the Pareto chart. So if we say bar graphs, the bar graphs are used for the distribution of nominal or ordinal level data. So a bar is drawn for each category where the height of the bar represents the frequency or number of members of that certain category. Now, since there is no numerical relationship between the categories in nominal data, then the various groups can be arranged along the horizontal axis in any order. And take note that the bars for each category in a bar graph do not touch each other, okay? So this further emphasizes the lack of quantitative relationship between the categories. On the other hand, if we say histogram, the histogram is used to represent frequency distributions composed of interval or ratio data. So it resembles the bar graph, but with the histogram, a bar is drawn for each class boundaries. So the class boundaries or true limits are plotted on the horizontal axis such that each class bar begins and terminates at the real limits of the interval. And the height of the bar corresponds to the frequency of the class interval. And since the intervals are continuous, the vertical bars must touch each other rather than be spaced apart, unlike the bar graph. And also we have the line graphs. So the line graphs are used to summarize how two pieces of information are related and how they vary depending on one another. So the numbers along each side of the line graph are called the scale. So each variable is plotted along an axis, and a line graph has a vertical axis and a horizontal axis as well. And also we have the frequency polygon. So what do we mean by frequency polygon then? A frequency polygon is also used to represent interval or ratio data, and the horizontal axis is identical to that of the histogram. However, for this type of graph, instead of using bars, a point is plotted over the midpoint of each interval at a height corresponding to the frequency of the interval. So the points are then joined with straight lines. And finally, the line joining the points is extended to meet the horizontal axis at the midpoint of the two class intervals, falling immediately beyond the end class intervals containing scores. So this closing of the line with the horizontal axis forms a polygon from which the name of this graph is taken. And aside from that, we also have the OGIV, or cumulative frequency polygon. So the main use of a cumulative frequency polygon is to estimate percentiles. So it is often presented in the percentage terms. And since cumulative frequency polygons estimates percentiles, both percentiles and percentile ranks can be read directly off the cumulative percentage curve. And the cumulative percentage curve is also called an OGIV. And lastly, we have the pie chart. And the pie chart is a circle graph divided into pieces, each displaying the size of some related piece of information. So pie charts are used to display the sizes of parts that make up some whole. And finally, the last example of a descriptive tool is numeric summary values, which includes numbers, percentages, and proportions. And the second division of statistics, or statistical treatment, is what we call the inferential statistics. And if we say inferential statistics, it pertains to the methods of dealing with making inferences, estimations, or predictions about a larger set of data using the information gathered from a subset of this larger set. So with inferential statistics, the researcher is trying to reach conclusions that extend beyond the immediate data alone. For example, we use inferential statistics to try to infer from the sample data what the population might think, or we use inferential statistics to make judgments of the probability that an observed difference between groups is a dependable one, or one that might have happened by chance in this study. Therefore, we use inferential statistics to make inferences from our data to more general conditions. Examples of inferential tools is, first, we have hypothesis testing. And if we say hypothesis testing, it is an area of statistical inference in which one evaluates a conjecture about some characteristic of the parent population based upon the information contained in the random sample. Usually, the conjecture concerns one of the unknown parameters of the population, and the goal of statistical inference is to be able to draw valid inferences or generalizations concerning the population under study based on evidence from observed samples. Another important concept underlying our reasons for performing tests of hypothesis is the concept of statistical significance. So this concept is very important to understand as it plays a vital role in the interpretation and evaluation of results in research and other situations involving decision-making based on observed samples. In hypothesis testing, we can make use of either t-test or f-test. Now, when an f-test is used to test a hypothesis concerning the means of 3 or more populations, the technique is called analysis of variance, or commonly abbreviated as ANOVA. Now, at first glance, one might think that to compare the means of 3 or more samples, the t-test can be used, comparing two means at a time. However, the t-test is not good in situations calling for the comparison of 3 or more groups. It can only compare one group's mean to a known distribution or compare the means of 2 groups. So with 3 or more groups, the t-test is not an effective statistical tool because the rest of the means under study are ignored. And another example of inferential tool, we have confidence interval, and we also have chi-square test. Now, generally speaking, the chi-square test is a statistical test used to examine differences with categorical variables. So there are a number of features of the social world which are characterized through categorical variables, may it be religion, political preferences, etc. So to examine hypotheses using such variables, use the chi-square. Another example of inferential tools that would be correlation. And under correlation, we have Pearson correlation, Kendall rank correlation, Spearman correlation, and point biserial correlation. If we say Pearson R correlation, Pearson R correlation is the most widely used correlation statistic to measure the degree of the relationship between linearly related variables. For example, in the stock market, if we want to measure how two stocks are related to each other, then Pearson R correlation is used to measure the degree of relationship between the two. And on the other hand, if we say Kendall rank correlation, Kendall rank correlation is a non-parametric test that measures the strength of dependence between two variables. So if we consider two samples, A and B, where each sample size is n, we know that the total number of pairings with AB is n times the quantity of n minus 1 divided by 2. And also, if we say Spearman correlation, Spearman rank correlation is a non-parametric test that is used to measure the degree of association between two variables. So the Spearman rank correlation test does not carry any assumptions about the distribution of data and is the appropriate correlation analysis when the variables are measured on a scale that is at least ordinal. And also we have point biserial correlation. If we say point biserial correlation, it is conducted with a Pearson correlation formula, except that one of the variables is dichotomous. And another example of inferential tool is what we call the regression analysis.
Now, in order for us to better understand the differences between descriptive and inferential statistics, let's have examples. Okay, in descriptive statistics, our first example would be a college dean wants to determine the average semestral enrollment in the past 5 school years. So the verb that we may use is determine, meaning to say our college dean is just trying to describe, okay? Just trying to describe, just trying to know the average semestral enrollment in the past 5 years. In contrary, in inferential statistics, a college dean wants to forecast the average semestral enrollment based on the enrollment for the last 5 years. So meaning to say, the college dean wants to forecast what will be the average enrollment, making use of the historical data, okay, the 5 school years for the past 5 school years. Another example under descriptive statistics, a businessman wants to know his profit for the past 3 months, okay? So the verb that was used is know, meaning to say the businessman is just trying to know, just want to describe his profit for the past 3 months. And in contrary, in inferential statistics, a businessman would like to estimate his profit for the next 5 months. Okay, so that makes it inferential because the businessman is trying to do estimation of his business profit. And the last example under descriptive statistics, a chief nurse wants to determine the average number of COVID-19 patients during the last 6 months, okay? So still, this is an example of descriptive statistics because we are using the verb determine. We are just trying to know, we are just trying to describe, and we are not trying to make inferences. So in contrary, in inferential statistics, a chief nurse wants to predict the number of COVID-19 patients for the next 2 years. And because it's predicting something in the future. So that makes it an example of inferential statistics. All right. So moving on to population versus sample. So what is the difference between the two? If we say population, it refers to the collection of all cases in which the researcher is interested. In its general sense, this pertains to the totality of objects, animals, persons, materials, happenings, or events under investigation. On the other hand, if we say sample, it refers to a portion or a subset of the population from which the information is gathered. So theoretically, a sample must be a representative of the population from which it is taken. Now, in order for us to better understand the differences, let us have some examples. Okay, first example of population. All students of ABC University. Okay, so all, you're making use of the word all. Okay, that's population. So how do we make this example as a sample example? So to make this as a sample example, engineering students of ABC University. Okay, because engineering students of ABC University are just representative samples of the totality of all students of ABC University. Okay, another example would be all patients of surgical ward in a hospital. And on the sample example, patients of surgical ward in hospital with respiratory complications. So out of all the patients in the surgical ward, you actually categorize the illness of the patient. So in order to make it a sample example, so patients of surgical ward in a hospital with respiratory complications or with COVID-19 complications, okay? And the last example, all companies manufacturing candies. And under sample, companies manufacturing candies that have employees less than 300, okay? So I hope this is clear. This is just very easy because a population, the totality of objects, population, etc. While a sample is just a representative of the population from where it is taken. The next key area that I'm going to be discussing right now, that would be the types of data. And under types of data, we have two special definitions. First, variable, and second, we have data. What's the difference between the two? If we say variable, it is a characteristic, description, or attribute of persons or objects which assumes different values or labels. And if we say data, it is a collection of variables. Now, in order for us to better understand the difference between the two, let us have some specific examples. So let us discuss first examples under variable. So under variable, going back to our definition, it is a characteristic, description, or attribute of persons or objects which assumes different values or labels. For example, we have height, age, and weight. So height is 5 feet 4 inches. For the weight, you have 120 kilograms. And for the age, you have 20 years old. So in a classroom setting, and there are, let's say, 20 students, of course, the height, age, and weight will vary because not all students have a height of 5 feet 4 inches, right? There are some who are 6-footer, and there are some who are below 5, okay? And the weight as well and the age. Another example would be gender, religion, affiliation, and civil status. For gender, it's either male or female. Religious affiliation, you have Roman Catholic. either Adventist, Protestant, Mormons, etc. And for civil status, you have single, married, separated, or widowed. Okay, so these are examples under variables. So what are the classifications, the two classifications of variables? Under variables, we have two classifications. We have qualitative variables, and we also have quantitative variables. If we say qualitative variable, this yields categorical responses. Examples: civil status, okay? Religious affiliation. So meaning to say, in qualitative variable, you need to always remember that we are only talking about the attributes, the characteristics of a certain person, object, and so on. We are not talking about numbers. This is not numeric in nature, okay? So that is qualitative. What about quantitative variable? If we say quantitative variable, this yields numerical responses representing an amount or quantity, meaning to say this is the complete opposite of qualitative, because quantitative is numeric in nature. For example, number of children in the family, blood pressure, and a lot more. And there are two types of quantitative variables. First, we have discrete quantitative variables, and second, we have continuous quantitative variables. So what's the difference between the two? Okay, when we say discrete quantitative variable, it assumes finite or countably infinite values such as 0, 1, 2, 3, and so on, and are usually obtained through the process of counting. For example, number of students, number of patients. So the very thing that we should always remember if we talk about discrete, first, it is countable, and second, it should always be whole number, okay? So this should be countable and whole number. On the other hand, if we say continuous quantitative variable, it assumes values which are associated with points on an interval of the number line, meaning to say, if your discrete is a whole number, your continuous is not, because there are points or fractional in nature. For example, height, okay? Others have 5 feet 1 inch, 5 feet 4 inches, okay? For the weight, you have, let's say, 50.55 kilograms, right? Or 70.8 kilograms. For the temperature as well, okay? So there are points on an interval of the number line, okay? And as mentioned earlier, we have 4 types of scales of measurement or data. Variables can also be classified according to the levels of measurement. First, we have nominal data. Second, we have ordinal. Third, we have interval. And fourth, we have ratio data. Okay, just a brief recap on this, since we already discussed this one in the earliest part of our discussion or lesson. If we say nominal data, it uses numbers or symbols for the purpose of categorizing subjects into groups or categories which are mutually exclusive. And again, the keywords that we should always remember if we talk about nominal data, that would be first, to name, and second, to label. Okay, examples are gender and college year level. On the other hand, we have ordinal data. Ordinal data possess all the properties of nominal data, and therefore, it is an improvement of the nominal data, because in here, the data are ranked or ordered in somewhat bottom to up or high to low schemes. Again, in ordinal data, the keyword that we should always remember is to order. So it's either bottom to up or high to low. Examples: students' class standing. So there is an order. from a point scale of 1 to 5, where 5 is the highest and 1 is the lowest. So in this case, 5 is excellent, 4 is very good, 3 is good, 2 is fair, and 1 is poor. So we are just simply ordering our data. And for the next scale of measurement, we have interval data. It possesses all the properties of nominal and ordinal data. And so for that matter, the data are numeric in nature, and the distances between two numbers are known. And again, as discussed earlier, I would like to reiterate, your interval data doesn't have an absolute zero. No absolute zero. Examples, IQ scores of 4 students. You have 70, 140, 75, 145, okay? And next, we have ratio data. And remember that ratio data possess all the properties of nominal, ordinal, and interval data. It is also numeric in nature and has an absolute zero. Examples, your age, your monthly income, your exam scores, etc. Okay, so these are the levels of measurements or data or scales of measurements. And remember that there are also other classifications of data. Data are classified into raw data and grouped data as well. So what is the difference between the two? If we say raw data, these are those which are in their original form and structure. If we say they are in original form or structure, they are actually not arranged yet. They are not arranged into some sort of an array, okay? These are raw data which are in original form or structure. Examples, responses out from surveys. So these are raw data. Taped interviews, recorded observations, and a lot more. On the other hand, if we say group data are those placed and summarized in tabular form. Okay, you are already grouping this and summarize this into some sort of a tabulation. Okay, these are the difference between the other classifications of data. We have the raw data and the group data.
So what are the roles of statistics in research then? Well, with the advent of the computer age, statistics is now playing a vital role in research. Now, this is true, especially in science and technological research. So what functions do statistics perform in research? Some of its functions are, first, statistical methods help the researcher in making his research design, particularly in experimental research. So here, statistical methods are always involved in planning a research project because in some way, statistics directs the researcher how to gather his data. And second, statistical techniques help the researcher in determining the validity and reliability of his research instruments, meaning data gathered by the researcher with instruments that are not valid and reliable are almost useless, and so the researcher must have to be sure that his instruments are valid and reliable. Take note, statistics helps him in doing this. And third, statistical manipulations organize raw data systematically to make the latter appropriate for study. Now, unorganized data cannot be studied. No inferences nor deductions can be made from unorganized data. And take note, statistics organize data systematically by ordered arrangements, ranking, score distribution, class frequency distribution, or even cumulative frequencies. Now, these make the data appropriate for your study. And number 4, statistics are used to test the hypothesis. Now, statistics help the researcher determine whether his hypotheses are to be accepted or to be rejected. And number 5, statistical treatments give meaning and interpretation to data. What do we mean by this? Well, for example, if the standard deviation of the class frequency of a group is small, we know that the group is more or less homogeneous, but if it is large, the group is more or less heterogeneous. And finally, statistical procedures are indispensable in determining the levels of significance of vital statistical measures. Now, these statistical measures are the basis for making inferences, interpretations, conclusions, and generalizations as well. Now, some guidelines in the selection and application of statistical procedures. Here, the researcher must have at least a rudimentary knowledge of statistics so that he will be able to select and apply the appropriate statistical methods for his data. Now, some suggestions for the selection and application of statistical techniques are the following. First of all, the data should be organized using any or all of the following, depending upon what is desired to be known or what is to be computed. Let's say telegram for tabulation table, ordered arrangements of scores, maybe, or score distribution, class or grouped frequency distribution, scattergram, etc. And for number two, when certain proportions of the population based on a certain variable such as age, height, income, etc., are desired to be known, then frequency counts with their frequency percents may be used. Now, for further analysis, cumulative frequencies up and down with the respective cumulative frequency percents up and down may also be utilized. For example, a specific question is, how may high school science teachers of Province A be described in terms of sex? Now, the males were counted and the females were also counted, and the respective percent equivalents were computed. Okay, so number three, when the typical, normal, or average is desired to be known, then the measures of central tendency, such as the mean, median, and the mode, may be computed and used. And for number four, when the variables being studied are abstract or continuous such that they cannot be counted individually, such as adequacy, efficiency, excellence, extent, seriousness of problems, and the like, then the weighted mean may be computed and used if the average is desired to be known. Now, the variable is divided into categories of descending degree of quality, and then each degree of quality is given a weight. For example, the question is, how adequate are the facilities of the school? Adequacy may be divided into 5 degrees of quality, such as very adequate with a weight of 5, adequate with a weight of 4, fairly adequate with a weight of 3, inadequate with a weight of 2, and very inadequate with a weight of 1. Then the weighted mean is computed. Okay, and for number 5, when the variability of the population is desired to be known, then the measures of variability, such as the range, quartile deviation, average deviation, or the standard deviation, may be computed and used. So when the measure of variability or dispersion is small, then the group is more or less homogeneous. But when the measure of variability is large, then the group is more or less heterogeneous. And for number 6, when the relative placements of scores or positions are desired to be known, then ranking, quartile, or percentile rank may be computed and used. Now, these measures indicate the relative positions of scores in an ordered arrangement of the scores. And number 7, when the significance of the trend of reaction or opinion of persons as a group toward a certain issue, situation, value, or thing, this is desired to be known, but in which there is a neutral position, then the chi-square of equal probability single group is computed and interpreted. And for number 8, when the significance of the difference between the reactions or opinions of two distinct groups in which there is a neutral position is desired to be known, then the chi-square of equal probability to group is computed and used. Now, in order for us to better understand this, let me give you an example. So, for example, a group of 50 persons, that's 50 persons, 25 males and 25 females, were asked to give their reactions to increasing the number of curricular years in the elementary school. Now, their reactions may be strongly agree, undecided, or no opinion, disagree, or strongly disagree. Now, if the persons are considered as a group, the chi-square of equal probability single group is computed as in number 7. However, if the significance of the difference between the reactions of the males and those of the females is to be studied, then the chi-square of equal probability to group is applied as in number 8. And number 9, to determine how one variable varies with another, then the coefficient of correlation is computed. As for instance, how the scores of a group of students in mathematics test vary with the scores of the same group of students in an English test. Now, this is also used to determine the validity of a test by correlating it with a test of known validity. When the coefficient of correlation between the two tests is known and a prediction is to be made as to what score a student gets in a second test after knowing his score in the first, and the so-called regression equation is to be utilized. And for number 10, if the significance of the difference between the perceptions of two groups about a certain situation is to be studied, then the computation of the difference between means is to be made. For example, is there a significant difference between the perceptions of the teachers and those of the students about the facilities of the school? To answer this question, the significance of the difference of two means is to use. Now, the statistical measure computed is called T. The T is also used to determine the usefulness of a variable to which one group called the experimental group is exposed and a second group called control group is not exposed. For example, the question is, does guidance improve instruction? Create two matched groups and expose one group to guidance while the control group is not exposed to guidance. So at the end of the experimental period, give the same test to two groups. Then compute the T, which will show if guidance is an effective aid to instruction. And number 11, to determine the relative effectiveness of the different ways of doing things to which different randomized groups are respectively exposed to, and only a post-test is given to the different groups, then analysis of variance is appropriate to use, or the ANOVA. For example, a teacher wants to find out the relative effectiveness of the following methods of communication. We have pure lecture, lecture demonstration, recitation discussion, and seminar type of instruction in science. Now, 4 groups of students are formed randomly and each assigned to one method. The 4 groups study the same lessons and after a certain period, given the same test, by analysis of variance, the relative effectiveness of the 4 methods will be revealed. So if the 4 groups are given a pre-test and a post-test, then the analysis of covariance is utilized, all right? And number 12, to determine the effects of some variables upon a single variable to which they are related, partial and multiple correlations are suggested to be used. For example, the question is, which is most related to the passing of a licensing engineering examination, college achievement grades, or percentile ranks in aptitude tests, general mental ability tests, vocational and professional interest inventory, or national college entrance examination? The process of partial and multiple correlation will reveal the pure and sole effect of each of the independent variables upon the dependent variable, the passing of the licensing examination. And finally, to determine the association between two independent variables, the chi-square of independence or chi-square of multiplication may be used. So the question answered by this statistical process is there an association between education and leadership, or the level of education and the ability to acquire wealth, or between social ability and economic status? Indeed, there are lots of research situations in which different statistical procedures may or can be used, and if the researcher is not so sure that he is in the right path, he better consult good statistical books or acquire the services of a good statistician plus the services of a computer, especially if the statistical procedures are complex ones. All right, I think that's a good place to stop. If you have questions, please let me know in the comment section below. And if you like this video, please don't forget to subscribe and hit the bell button for the latest updates. Thank you.